Hello guys, you're welcome to this lesson. In this lesson, I'm going to look at how to calculate the amount that remains, or the initial amount when a particular radioactive element undergoes decay within a specific time range, and then when you are given the half-life. Is that okay? In our previous examples, we did calculation for the time and also decay. Now let's look at when you're also asked to calculate the initial or the final amount of the radioactive element. How do we go about situations like that? Is that okay? Now let's look at the question we have on the board. So we have a question on the board. The question says, gold 198 is used in the diagnosis of liver problems. The half-life of gold 198 is 2.69 days. So these are half-life, so these are T half. If you begin with 2.8 gram, so the 2.8 gram indicates the what? The initial amount. And the initial amount we know is denoted by the N naught. Is that okay? If you begin with 2.8 grams of this gold isotope, what mass remains? So what mass remains? The mass that remains is N after 10.8 days. The 10.8 days here indicates what? The time T. Is that okay? How do we calculate for the final amount, that is the N? So I've given you the relations here already. We have T half being equal to ln 2 on K, or K is equal to ln 2 over T half, where ln 2 can be also approximated to 3 places of decimal, being equal to 0.693. Is that okay? Another relation is ln of the N on N naught is equal to minus KT. So we usually use this one in questions when we are asked to calculate the T. If you know the N and then the N naught, it becomes very easy for you to go with this relation, this 2 and 3. In questions when we are asked to calculate the initial amount or the final amount of the radioactive element within a specific time and then a stated half-life, you should usually use this relation. That is relation 4 or 5, any of them. Is that okay? For your calculation, it is very easy to use this relation whilst using this one because the mathematics become very simple. Is that okay? Alright, so now let's write our data first and then let's go through. So we have our solution. We have our T half to be equal to 2.69 days. In addition to that, we have our N naught. Our N naught is 2.8 grams. Our N, we don't know. Our time, T, is 10.8 days. Is that okay? So we are asked to calculate for N. So we can use relation 4 or 5. So let's take relation 5. So relation 5, we have N naught over N is equal to E exponent KT. Is that okay? Alright. Do we have K? We don't have K here. Do we have T? We have T here. Do we have N? We don't have N. Do we have N naught? We have N naught here. So first of all, we need to calculate for the K. Is that okay? How do we get the K? So from the first relation, that is T half is equal to ln 2 on K, we can equally make K the subject once we know the half-life. So K becomes ln 2 on T half, that is the half-life. And indeed, in the question we're given the half-life, and that is 2.69 days. Is that okay? So now let's calculate for K. So our K will be equal to what? Ln 2 on T half. So we can approximate ln 2 to 3 places of decimal to be equal to 0.693 divided by T half. And what is our T half? 2.69. So with the help of our calculator, we can punch 0.693 divided by 2.69. and that will give us our k to be equal to 0.258. 0.258 once you are considering 3 places of decimals. So 0.258 per days, because the half-life was given in days. And looking at the relation, it becomes 1 over day, so per day. Is that okay? So this is our k. Now, it is not just the k that we need. We are asked to calculate the amount that remains, that is the n. Is that okay? So let's then proceed. So now we have our k. So from the relation, n naught over n is equal to ekt. We now know our t, we now know our k. Is that okay? So what is our n naught? Our n naught was giving us 2.8 divided by our n. We don't know n. Is that okay? So the e here is just the inverse of the length. The length inverse. So you can just press shift and then length, you get your base here. And then you just enter the values. We have raised to the exponent k, that is 0.258 times our t, 10.8. So we are going to get 16.223 when it is being approximated to 3 places of decimals. Is that okay? So once we get to this point, we can do cross multiplication. So we can say that 16.223 n is equal to 2.8. So we can divide both sides by 16.223 and here too by 16.223. Is that okay? So here we can equally say that this one is going to be eliminated. So we now have n to be equal to 2.8 divided by 16.223. So we have in a fraction with numerator 2.8 and then the denominator 16.223. And then we have n to be equal to 0.173 grams. That is when it is approximated to 3 places of decimal. Since the initial one was given in 1 place of decimal, let's make it 0.2 grams. So the amount that remains becomes 0.2 grams. The amount that remains becomes 0.2 grams if it is approximated to only 1 place of decimal. Is that okay? So in questions that you are asked to calculate the amount that remains or even the initial amount, we can simply go for these one. Is that okay? Why? Because the e here is just the lane inverse. It's just the lane inverse and it's on the calculator, so you can just punch it and then just enter your k and t value. So we calculated for the k, but the t was given to us in the question. So it will look like we just have a simple linear equation in a fractional form. And then you just find the variable that you want. Very, very simple and straightforward. Is that okay? So this is how we go through a question where you are asked to calculate the amount that remains or the initial amount. If it were to be the initial amount, the same thing. So that would have been, we will have the value for this. Sorry, we will have the value for this, but not the value for this. You still get a linear equation in a fractional form. You just do cross multiplication. You get the linear equation straight away, just find for the variable, and that is all. Is that okay? Thank you.